morning, grade 7 students. We will continue today the lesson about pure substances and mixtures. We have started this lesson. I'm going to repeat part of it, but I will remind you of the part that we have done and you were asked to practice it this week or last week. To identify a pure substance and a mixture, we can depend on characteristic properties like boiling point. And we concluded that the boiling point of a pure substance is constant, while the boiling point of a mixture is variable. Today we will continue to talk about a pure substance in details and then how to classify a pure substance. What is a pure substance by definition? By definition, a pure substance is a substance that has definite physical and chemical properties. We said definite physical and chemical properties like that of water. When we say that the boiling point of water is 100 degrees Celsius, 100 degrees Celsius is a definite physical property. While as if we said that iron has the ability to rust, or iron can react with oxygen in the air. This is also another definite chemical property. Uh, why do they have definite physical and chemical properties? They have definite physical and chemical properties because they are made up of one type of particles. We used to say they have identical particles. Each pure substance has identical particles. What are pure substances? To identify a pure substance, first, we should say that they are made up of identical particles. Second, they cannot be formed or broken down by physical means. In the coming slides, we are going to explain each item. Now we will start with the first item. Pure substances are made up of identical particles. Let's take, for example, this model. Let's take just one particle. Compare it now to the rest. Are all the particles alike? Yes. Are they made up of one kind of atoms or more than one kind of atoms? They are made up of one kind of atoms and all the particles are identical. All the particles are identical, so it's a pure substance. It's made up of one kind of atoms. It means that it is an element. Let us take the second model. Let's take one particle only. Just take one particle. Now compare this particle to all the rest. Are all the particles alike? Yes, they are. Each particle, of how many atoms is it made? Each particle is made up of two atoms. Are the atoms alike or different? They are alike. So, this is a pure substance and made up of one kind of atoms. But each particle is made up of two atoms that are combined together chemically. We call it an element because the atoms are alike. While as the third, let's take one particle. Now compare it to the rest. Are all the particles alike? Yes, they are. They are made up of one red atom and three yellow atoms. All of the other particles are alike. Now let's take one particle in the third diagram. Are all the atoms alike or different? They are different and they are combined together chemically. So it is a pure substance because it has identical particles. It is a compound because each particle is made up of different kinds of atoms that are chemically combined. Now let's consider the second part of the slide before. Pure substances cannot be formed or broken down by physical means. Let's see this ice cube. The ice cube is melting. When it melts, does it change its identity? Does it become something new, new matter, or it stays the same? You might say it changes, but it changes the state, but it does not change the identity because the ice will become water and the water can be frozen again and it becomes ice. So the identity did not change, only the state changes. Now, let's look at the second figure. We have a paper and you are cutting it with a scissors. What happens to this substance when you cut it? Does it change identity? It becomes something new? You are cutting it into smaller particles or not? Of course, it's not. You are not able to change it into any simpler substance by physical means. What do we mean by this expression, physical means? It means like making physical changes, like cutting, crushing, melting, freezing, and so on. How are pure substances classified? Pure substances are classified then into elements and compounds. Both elements and compounds are made up of particles, and all of the particles are identical for each kind of element or each kind of compound. How can elements be recognized? To identify an element, you can depend on its physical and chemical properties. Physical and chemical properties, we have studied them in lesson 2 in this year. The elements, you can find them in the periodic table at the beginning of your agenda. These elements are all pure substances. They are made up of one kind of atoms. That's why you will never find water or salt or even sugar in the periodic table. How are elements classified? Elements are classified into metals, metalloids, and nonmetals. Metals and nonmetals are easy to understand, but metalloids comes from semi. It's like half half. Let's see what does it mean exactly in the coming slides. What are the properties of metals? First, metals are solids except mercury, like gold, silver, aluminum, calcium. All of them, they are solids. Only mercury, the liquid that you can find it in thermometers, the traditional ones, and it is silvery, it has a silvery color. It is a liquid. Metals are hard and shiny. Hard, it means that they cannot be broken easily. Shiny means they can reflect light. Like the gold, they have a shiny appearance. Metals are ductile. Ductile means that they have the ability to be stretched into wires. Malleable means that they have the ability to be hammered into sheets. Like gold, 1 gram of gold, you can hammer it to give you a very thin sheet that is 1 meter squared. Metals are good conductors of heat and electricity. Good conductors, it means they allow the heat or the electricity to pass through them. At the end of the slide, I have um, added a link for a video to show you how metals are good conductors of electricity, but you have to click on the link. So please click on the link in order to watch the video. Metals have high melting and boiling points and high density. This is one of the best ways in order to recognize a metal. If a metal needs to melt or boil at high temperature, you directly can recognize it as a metal. If not, it will not be a metal. Also, their densities are high. Like gold, it has a density of 19.3 grams per centimeter cube, which is of a very high density. This is all for metals now. Let's see nonmetals. What are the properties of nonmetals? Nonmetals, you can find them as solids, liquids, or gases, but mainly they are gases. If they are solids, usually they are brittle and dull. Brittle means if you hammer them, they will shatter and they will not be changed into sheets. While as dull, it means they don't reflect light. Nonmetals are not ductile or malleable. Ductile, they cannot be drawn into wires. Malleable, they cannot be hammered into sheets. Nonmetals do not allow heat or electricity to pass through, so they are poor conductors. Nonmetals have low melting and boiling point, like oxygen and hydrogen. They can become liquids and gases at very low temperature, even below zero, very low temperature below zero. And it has very low density. Let's now see what are the properties of metalloids. Metalloids have some properties of both metals and nonmetals. You cannot really decide. Their name metalloids, it means they are semi. It means half-half. Silicon is one of the most important elements used nowadays. You can find silicon mainly in computers, computer chips, your laptops, your mobiles, tablets, etc. What's so special about this silicon? Silicon, it's solid, so it's like a metal, but it has a low density. It means that it's not like a metal. It's high strength, it's strong, it's hard, so it is like a metal. It has low thermal expansion. It means it cannot expand. High thermal conductivity. It allows heat to pass through it. In fact, it allows the electric current to pass through it very well. That's why it is used inside your computers and as silicon chips. And also it is hard. So as you can see, silicon, it has some properties of metals and nonmetals. That's why we say that it belongs to metalloids, not metal, not it's not a nonmetal as well. On this slide, uh, you have a link. You can click on it. It will take you to YouTube where you can watch a video How to test if it is a metal or not? By using conductivity or the ability to conduct an electric current.